Welcome to Rise, an edutech platform for JEE and NEET. In this video, we'll be discussing about the analysis of Rise All India Mock Test Series 1 that was held from Jan 24th to Feb 21st. We'll be discussing the analysis and the anticipated questions in the mock test. For physics, I am Vamsidhar, IIT Madras alumnus, and I'll be discussing the analysis part of the mock test. So in this analysis will be covering All India Mock Test Series analysis, that is the distribution of questions in different mock tests, and previous year paper analysis of important topics, followed by video solutions of anticipated questions by Jayaram. Now let us look at the All India Mock Test Series analysis. Rise has identified the top 10 chapters which are contributing more than 50% in the final JEE exam every year. So in these 10 chapters, the probability of questions have been analyzed based on the previous year paper and how frequently they are coming in the previous year papers. So by preparing for these 10 chapters in the last few days, you will be able to score better in your final exam. So in this way, by students who have attended these mock tests, they will be able to perform better because they've got practice from various topics within these important chapters. Now let us look at the previous year analysis of important topics. So in each subject, the chapter group has been identified and the important chapters in that particular chapter group are given here. In electric current, electricity, electrostatic potential and capacitance, and alternate current. These are the three important topics, and 10 questions have been anticipated from this particular chapter group, where 4 important topics under current electricity, 3 important topics under electrostatic potential and capacitance, and 3 important topics in alternate current have been considered. Going to the next chapter group, that is thermal physics, there is one important topic, that is thermodynamics, from which frequently questions are being asked in previous year papers, and ray optics and optical instruments in optics, and 3 topics from thermodynamics and 4 topics from ray optics and optical instruments are prioritized as important topics because of the frequency of the questions that are being asked in the previous year papers, and 7 questions are anticipated from these 2 chapter groups. The next chapter group, mechanics, which is important for any JEE Mains aspirant to prioritize, and the important chapters in this are rotational motion, work, power and energy, and properties of liquids, and 3 important topics from rotational motion, 2 from work, power and energy, and 2 important topics from properties of liquids. So a total of 7 questions from this chapter group were given. And coming to the modern physics, every year questions will be asked from semiconductors and devices and dual nature of radiation chapters, and within these chapters there are 5 important topics and 5 questions have been anticipated for the final exam. So in this way, considering all these important topics, 30 anticipated questions are given in the mock test that was held on Feb 21st, and the video solutions will be discussed by JEE faculty Mr. Jayaram.
Today we are going for a JEE Mains 2021 anticipated questions. So we are expecting this type of the questions that might be coming here. So the first question that we are going to discuss is a work function he has given, and it's basically the question from the photoelectric effect. So we know the photoelectric effect conditions that is based upon the Einstein's energies. So given question is the work function for the surface of aluminum. He has given the work function here. How much potential difference will be required to stop the emission of maximum energy electrons emitted by light. This is an incident light. So for this particular thing, the Einstein's energy will be going for, that is E is equal to work function plus kinetic energy, and your stopping potential will be nothing but a numerically equal to your kinetic energy. So from the given relation you can find the incident energy is 12400 by given wavelength lambda. So the given wavelength lambda is going to be 2000 angstroms. So from this one you can calculate the incident energy, and he has given the work function to be the 4.2 electron volts. So this is the one he has given. Now required kinetic energy can be calculated as an E minus work function, so which will be approximately, this goes for here, so somewhere around this will be the, so 124 by, this is calculate, you can get this one, from this one you can get the kinetic energy in electron volts, and that kinetic energy will be approximately 1.99 electron volts, and kinetic energy in electron volts is numerically equal to the stopping potential. So this will be your answer for the corresponding thing, sir. So this you can go here. Next one, so he has given in the second question, this question consists of the current, electricity, and regarding that, so voltmeter. So the voltmeter is giving a full scale deflection here, deflects to full scale. So full scale deflection, he has given potential difference of 5 volts across it. It is also made by connecting a resistance Rx in series. This is another important one. And galvanometer resistance he has given, let us take it as a G, so which gives a full scale deflection of the potential, that is 20 milliamperes across it. So this is the question which is concerned to an current, electricity, and in this one conversion of the galvanometer into an ammeter conditions, this one. So how to solve this particular case, please? So in this case, which is an, this is already an voltmeter which is measuring, giving certain values to it. So from this one you can find the current passing through this one, because you are going to connect another resistance in series which should not change the value of the current passing through that one. So by substituting values in this one, that is 20 into 10 to the power of minus 3 by, this is going to be the 80 conditions. So from this one you can get it as an 2.5 into 10 to the power of minus 4 amperes. This is the current that will be passing. Now the Rx value we need to find here. So V is equal to your current through the galvanometer, you can take this as a 1, into the resistance of the galvanometer plus resistance along the series Rx. So voltage it needs to be measured is 5 volts, and we have got the current as an 2.5 into 10 to the power of minus 4. Galvanometer resistance is 80, and this is your Rx. On solving this one you can get the Rx value to be somewhere around 19.92 kilo ohms. So that comes out to be your option C. Next one, coming to the third question. A round uniform body of the radius r and the mass m and the moment of inertia I rolls down the inclined plane without slipping. This is the case where pure rolling under the rotatory motion, it comes under the pure rolling conditions. Generally this we will be taking as a direct formula for the acceleration down the inclined plane. So we can derive this particular thing, it's a direct formula actually. If you derive, generally in lot of applications you might have derived. So this is a rolling object which has been rolling down here, so a uniform round object he has given without slipping, so we need to find out that particular thing, sir. So in this case the friction, since it has been rolling down, so in this direction you will have an mg sine theta, in the upward direction you will have an friction. So and the normal reaction will be in this direction, and you can have this one as an mg cos theta. So now as it is exhibiting pure rolling, means it will exhibit the translatory and rotatory motion. First one, translation equations here. Translation equations are, that is mg sine theta minus friction has to be equal to the m into acceleration. Coming for the rotational equations, so these rotational equations can be torque. We are going to go for the torque will be produced by only the friction. F into r is equal to I alpha. So use these relations and find out the value of the F into, or your friction Fr is equal to some moment of inertia I into this is A by R. You can take it and take out the R value, you can get the friction, this is IA by R square. So substitute this particular value in the equation number 1 and solve it. From that one you can get the solve for the acceleration. You can get the acceleration as n, that is g sine theta by 1 plus moment of inertia by this is mr square, or generally this will be taken as n, this is g sine theta by 1 plus k square by r square. Also this will be your acceleration condition, sir. Next one please. What is the minimum value of the refractive index of the prism? So this is our next question. What is the minimum value of the refractive index for 45 degrees? This is an angle of the prism which is used to turn the beam of the light into the total internal reflection. This question comes under the ray optics under the pure case. So under the ray optics also this will come for the refraction through the prism conditions. So it has to undergo the total internal reflection, and your angle of the prism is 45 degrees. So this is the value 45 degrees he has given. So it can undergo the total internal reflection. The A is let this falling perpendicularly onto this one, so it reflects downwards. This is your another case of this one. So in this case, what can be the refractive index? He is asking, that is refractive index mu is equal to 1 by sine C, where C is the critical angle. This is 45 degrees, this is also 45 degrees, so critical angle is also 45 degrees. So mu is equal to 1 by sine 45 degrees. So mu is equal to root 2, which is 1.41. So this will be your answer, 1.41. Next, coming to the another question, question number 5. 1 kg of copper rod rests on a two horizontal rails of 1 meter apart and carries a current of 50 amperes from one rail to the other. The coefficient of static friction between the rod and the rails is 0.6. He is asking the smallest magnetic field. Actually, it's a combination of the chapters. So in this one, the frictional condition is been there, that is loss of motion or frictional condition, and induced EMF is also there, that is an EMI conditions. So we need to apply the multiple conditions here, force and the torque situations. So coming to this one, let us have, and suppose this is our rail. Let us imagine in this case, for example, this is a rail. So in this case, the friction might be acting in this direction, and the weight of this rail might be acting in the downward direction, that will be the mg. So the force, the magnetic field will be acting in this direction, and your force because of the magnetic field might be acting in this direction, normal reaction, and making an angle theta here. So obviously force because of the magnetic field will also make an angle theta with the horizontal. So from this one, frictional force can be obtained as an mu s into normal reaction static conditions, and force because of the magnetic field can be written as an, it is BIL. So now what is happening here, the vertical component of this particular thing, or the magnetic field, whatever is there, the force value, that is the vertical component of the force which will be acting in this direction, that is FB sine theta is acting in upward direction, which is acting to the normal reaction. So that means FB sine theta plus normal reaction, this should be equal to the mg. From this one, FB means BIL sine theta plus normal reaction is equal to mg. This you can take it as an equation 1. And horizontal component of this one, that is BIL cos theta, will be equal to the frictional force, and that is equal to the mu s into n. This is your second equation. So now on solving this particular thing, substituting the n value from the equation 1 to the equation 2, you can find the b value to be, b is equal to mu naught into mg by, so this is IL into cos theta plus mu s into sine theta. So this is your magnetic field that can be applicable. So now for the minimum, for the b has to be the minimum. for B to be minimum, this cos theta plus mu s into sin theta, this should be the maximum. Okay, so for this has to be the maximum. That means differentiate this one with respect to the theta, and when you differentiate you will be getting that is the theta is equal to tan inverse of mu s, and the value will be that is 31 degrees. Substitute in this relation for the B minimum and you can find the B minimum value to be the 0.10 Tesla. Fine. So that means your option will be the first option in this case. Coming to the sixth question, the wire of the length 100 centimeters is connected to a cell of 2 volts and negligible internal resistance. The resistance of the wire is 3 ohms, he has given. The additional resistance required to produce a potential difference of 1 millivolt per centimeter he is asking. So the potential drop per unit length he has given. So that potential drop per unit length is 1 volt per centimeter he has given, millivolt per centimeter he has given. So how much potential drop per unit length we need? That is equal to the 1 millivolt per centimeter. This should be the potential drop per unit length. Now for this one, what he has done is he has taken an 100 centimeters long wire here, and this 100 centimeters wire having a resistance of 3 ohms. So this has been connected at the two ends, and here then series resistance he is connecting here, R value. So he is asking for this one he has connected a 2 volts cell, a 2 volts battery he has connected. This one is going to be your 2 volts. So now this is the one we need to be achieved. So how can we calculate this particular thing? This is potential drop per unit length is. So since this 3 ohms and R are in the series conditions, and this is the one which has been applied according to the potentiometer link, potential drop per unit length is equal to E by, that is an EMF in the primary circuit, and the net resistance of the circuit is 3 plus R into, this is 3 by 1 meter, or this can be written as generally the resistance of the potentiometer by total length. This is your resistance of the potentiometer, where small l comes out to be the balancing length. So this is 1 volt per millimeter in centimeter. So in the question only he has asked in centimeters, sir. So let's put out in the centimeter. This will be the 1 into 10 to the power of minus 3 is equal to E value battery 2 by, this is 3 plus series resistance R need to be connected into 3 ohms by 100 centimeters. This one I have. Now from this one we have to calculate R is going to be how much. So this is 3 plus R is equal to 6 by 10 to the power of minus 3 into 100. So this comes out to be the 3 plus R is equal to 10 power minus 1 will be left over, and this will be the 60. So from this one R is equal to 57 ohms. So this should be your answer. So 57 ohms, that is option B. Now coming to the next question of this one is, so this here the potential energy of a 1 kg particle free to move along the potential energy should V of x is equal to x to the power of 4 by 4 minus x square by 2 he has given. The total mechanical energy of the particle is 2 joules. He is asking the maximum speed. So how can you get this particular? He has given the potential energy there. He is asking the velocity is going to be how much. So what is the relation basically here? The total mechanical energy, that is the TE, is equal to the sum of kinetic energy plus potential energy. So potential energy should be the minimum he has asked. So to find the minimum potential energy, that is PE has to be the minimum. So differentiate that one, dV by dx should be equal to 0. And when you differentiate at the x values of 0 comma or x is equal to plus or minus 1, you can get, so the 0 cannot be a possible function because I'll be going for a plus or minus 1, then substituting in the V, or that is the potential energy here, the minimum value of the potential energy will be coming out to be the minus 1 by 4 joules. Substitute this one in the total energy. Your total energy is 2 joules is equal to kinetic energy minus 1 by 4. So kinetic energy is equal to 2 plus 1 by 4. So that comes out to be the 9 by 4, and equate it to the half m v square and solve it. For velocity you will be getting 3 by root 2 meter per second. So this should be your condition, sir. 3 by root 2 meter per second, that means your option A. Now coming to the next question, question number 8. A particle A has charge plus q and particle B has charge plus 4q, with each of them having the same mass. When allowed to fall from the rest on a same electric potential difference, is asking the ratio of the speeds of VA by VB will be how much. It's a chapter, it's a one concerned to the electric charges in the fields. So basically that you can go for this in depth. Specifically you can go for the electric charge. So in this one he is asking the velocity conditions. We know the force concept of this one, that is force between the charges, that is F is equal to, we can write it as an electric field into charge. From this one acceleration can be written as an EQ by M. Fine. So in this one, in the question, so what can be the acceleration based upon the charge values here? Acceleration of the A is equal to 1 by 4 of acceleration of the B based upon the charges having the same electric field. Substitute in the kinematical equations of V square minus U square is equal to 2A. Yes, their distances traveled is same, initial velocity will be same, so V square is proportional to the acceleration. So that means VA by VB is equal to root over acceleration of the A by acceleration of the B, which is comes out to be the 1 by 4, that is equal to the 1 by 2. So this is a very simple question, and direct forward questions, you should be very careful in these type of the questions. You should not lose them. Basically your option will be 1:2, that is option B. Now going to the next question, that is the question number 9, which is concerned to the units and dimensions, which is the first chapter of your first year or your 11th class. He has given the force of interaction between the two atoms. Some expression he has given, alpha beta e to the power of minus x square alpha kt, where x is the distance, k is the Boltzmann constant, and t is the temperature. Alpha beta are two constants. He is asking only one thing, that is dimensional formula for the beta. So how can you get the dimensional formula of the beta here? So for the given expression, I am repeating the given expression, force is equal to alpha into beta e to the power of minus x square by alpha kt. Since it is a number, so this term should be equated with some number, please. So that means x square by alpha kt should be equal to the m to the power of 0, l to the power of 0, t power 0. On solving this one, the dimensional formula of the alpha, you can get it, our alpha is equal to, this is equal to 1 if I take it, or alpha is equal to x square by, this is your kt, where x is your length, so that is nothing but your L square. Kt, that is Boltzmann constant, into the temperature can be nothing but, and this is equivalent to the energy, so that is L square by ml square t power minus 2. So from this one, alpha is equal to m inverse t square, and the product of the alpha and beta should be equal to the force. But the dimensional formula of the force is ml t power minus 2 is equal to alpha dimensional formula m inverse t square into beta. On solving this one, you will be getting the beta is equal to m square l t power minus 4. That is your option C. Now coming to the next question, that is 10th one. So in the 10th one, what he has given, a container open at atmosphere contains air at temperature 27 degrees centigrade. So this is the one at 27 degrees centigrade. The temperature is now raised to the 227 degrees centigrade. The number of atoms in the container now and at the beginning he is asking. So this is a pure case of the KTG, that is kinetic theory of gases. So how do we solve this particular thing? Just apply the basic conditions where the pressure and volume are the constant. That means N1, K1, T1 will be equal to the N2, K2, T2 you can go over, or nRT. From this one, N2 by number of moles N1 is equal to temperature T1 by temperature will be the T1 by this is T2. So what is the T1 value is 273 plus 27 by 273 plus 227. This comes out to be the 300 by 500, or it is 3 by 5 in the ratio. So 3 by 5, that means your option is A. Coming to the next question of us. The next question is a plane electromagnetic wave of frequency 50 megahertz traveling in the free space along the positive x direction. At a particular point in the space, he has given the electric field to be this one. The corresponding magnetic field, it's an electromagnetic waves. In that one, he is asking the relation between the electric waves and the magnetic waves. So what will be the relation between the electric waves and the magnetic wave is E by, that is electric field by magnetic field is equal to velocity of the light. From this one, B he is asking. So B is equal to, that is E by C. E given as an some 6.3, and you know the velocity of the light 3 into 10 to the power of 8 meter per second. On solving, this comes out to be the 2.1 into 10 to the power of minus 8 Tesla, and obviously this will be acting along the K direction, that is the K cap. So it's another simple question that you can expect from the electromagnetic waves. Please be careful of this one. Next, question number 12. An isolated sphere S of radius r carries an electric charge. It is carrying an electric charge. S is momentarily connected to a distinct uncharged sphere T. This is a very important statement. Of radius smaller, he is asking the surface charge densities are going to be how much. So up to what time you can expect the charge will be flowing from the one to the other. So S is a charged one, T is an uncharged one. Let some charge has been moved from the S to T until there potential of the S is equal to potential of T. Then why can't we equate them, sir? Q1 by 4 pi epsilon naught whose radius is R. This is some Q2 by 4 pi epsilon naught small r. So from this relationship you can get the Q1 by Q2 will be in the ratio of capital R by small r. But we know that the charges can be written as an surface area into charge density, surface charge density, which is 4 pi r square into sigma 1 by 4 pi small r square into sigma 2. On solving this one, you can get the sigma 1 by, that is surface charge densities are in the ratio of small r by capital R. Small r by capital R, that means your option is B. Coming to the next question, that is the question number 13. A steam engine operating between the boiler temperature 220 degrees centigrade and a condenser temperature 35 degrees centigrade delivers 8 HP, that is the power it has been delivering. If its efficiency is 30% of that of the Carnot engine operating between these temperature limits, how many calories are absorbed by each second by the boiler? So it's a thermodynamics where we are going to discuss about the heat engine concept. So in this case, how do you find out the, by the way, efficiency? So the efficiency can be calculated is, that is eta is only 30%, ma'am. That is eta is equal to, this can be written as an 1 minus T2 by T1. So only 30% of this efficiency has been working. So this can be written as an 30% of this one is, can be written as an, that is 0.3 is your 30% of 1 minus T2 sink temperature T08 by 493 Kelvin. We need to convert this one into the Kelvin, sir. So he is asking the input is going to heat is going to be how much. Always efficiency is equal to output work by input heat supplied. Okay, so from this one we need the input heat, or QIP I am writing here, is equal to work done by, that is output work done by efficiency. So now you can substitute everything here and solve this one, please. So that is 8 HP, that is a power, into convert the HP into the watts, 746 please, into 1 calorie by 4.184, convert the calories also please, by, this is efficient 0.113. On solving you will be getting it as an 12.7 kilocalories per second. So that means it should be your kilocalories per second, option A. Now coming to the question number 14. A cylinder of radius r made of the material of thermal conductivity K1 is surrounded by a cylindrical shell of inner radius r and outer radius 2r are made of the material thermal conductivity K2. The two ends of the combined system are made of the two different temperatures. There is no loss of heat across the cylindrical surface and the system in the steady state. Effective thermal conductivity, it is a chapter concerned to the heat transfer. In that one the topic is going to be the conduction. So in this conduction case, how can you solve this particular thing? There is a cylinder is there, he has given. So a cylinder whose radius is going to be the smaller, r, and this one is surrounded by, the thermal conductivity of this one is K1. It is surrounded by another cylinder whose outer radius is going to be the 2r. This is the one whose outer radius is going to be the 2r, but the thermal conductivity of the outer one is K2 and the inner one is K1. This is your K2. So what he is asking, sir, is asking the equivalent thermal conductivity is how much. So then what is an area of the inner one? The inner area can be written as an A is equal to pi r square, and the length of the heat is going to be travel, L1 is equal to L, and area of the second one, A2, is equal to pi into, it will be the 2r whole square minus r square. On solving this one you will be getting A2 as an 3 pi r square, and the length traveled of the heat in this second case is, that is outer cylinder, is also same. So as the tubes are going to be in the parallel combination, the total heat supplied H is equal to H1 plus H2. In this one the denominator L is same, so I am directly going for the, this is K equivalent into area, that is total area, which can be the 4 pi r square. Temperature difference delta theta is same, is equal to length traveled is L. This is K1 into pi r square into delta theta by L. Second one, K2 3 pi r square into delta theta by L. On solving this one you can get the K effective as, so K1 plus 3 K2 by 4. This is the one conditions. So that means your option will be the K1 plus 3 K2 by 4. This is the option D. Now coming to your next question, that is the 15th one. So what is this 15th question? While measuring the speed of the sound by performing the resonance column experiment, student gets the first resonance condition at length of 18 centimeters, that is L1. You can consider this as an, so this is your L1. During the winter, same experiment is repeated during the summer. He measures the column length to be X of the second resonance, that is L2. So what is the difference between the winter and the summer? As you know, the temperature increases, there will be change to the velocity of the sound, and it is concerned to the waves chapter, and in that one we are going to see the Argon Pipes topic. This is the one under the resonance column apparatus. So generally you will be getting the resonance. It's a closed pipe. So since it's a closed pipe, you can write the frequency F1 is equal to V1 by 4 L1, and where L1 is equal to given to be the 18 centimeters. So actually you should be getting the second resonating length, that is L2, as 3 times of L1. So it is 3 into 18, which comes out to be the 54. If the same experiment is been conducted in the winter, you should be getting this value. But since it is in summer conditions, velocity of the sound will be changed or increased, and correspondingly you should be getting the x value has to be greater than 54 centimeters. So this should be your condition, sir. Next one, that is coming to the question number 16. As shown in the figure, uniform solid sphere rolls on a horizontal surface 20 meter per second. Initial velocity he has given, sir. It then rolls up the incline shown. What will be the value of the h? Where the ball will stop? That means its final velocity has to become 0, and moreover it is pure rolling. Since it is under the pure rolling conditions, I am going for the law of conservation of energy case here. What is an initial energy is, that is half mv square for the translational plus half I omega square for rotation is equal to, that is mgh at the last conditions, please. So since it's a solid sphere, moment of inertia can be written as an I is equal to 2 by 5 mr square, and pure rolling omega is equal to replaced by the v by r. So substitute, cancel the mass on both sides, please. That is this one, and moment of inertia also. So you will be left with 1/2 into v square plus 1 by 5 into v square is equal to 9.8 into h. So since v is equal to 20 meter per second, so on solving this one, you will be getting the h to be as 28.6 meters. So this is another easy question for this one. 28.6, in the sense the option should be the first option. Coming to your next question, that is an 17th question. By looking at the diagram only, you can say this is concerned to the digital electronics condition, whose chapter is semiconductors. So let's go to the question. Given below are symbols for some logic gates, XOR gate and NOR gate respectively, he is asking. So XOR gate and the NOR gate will be what? So obviously your XOR gate is going to be this one, and NOR gate is going to be 3, that is your option has to be the 17. So this doesn't need any specific explanation, please, or else if you want any specific explanation, we can go XOR gate, that is X and OR gate, which is called as an exclusive OR gate, whose function will be like this: y is equal to a bar b plus a b bar. Second one, obviously NOR means your NOT gate plus OR gate. So options 2 and 3 already we have gone for the answer. Next, question number 18. A block of wood has a mass 25 grams. When 5 grams of metal piece with a volume of 2 centimeter cube is attached at the bottom of the block, the wood barely floats in the water. What is the volume V of the wood? It's an fluid statics, that is the mechanical properties of the fluids. It is concerned to the fluid statics, sir. So mass of the wood he has given, mass of the metal he has given, the volume which is being immersed over there. Okay, remaining thing he is asking us, sorry, what is the volume of the wood he is been given? He has given the volume of the metal piece is how much. Now go for the loss of flotation here, that is total weight acting in the downward direction, mass of the wood plus mass of the steel into G is equal to your buoyancy force, that is Fb. That can be written as an total volume of the wood plus volume of the metal into density of the water into G. G you can remove here. Mass of the wood is how much? 25 grams plus 5 grams is equal to volume of the wood. We have to find it out. plus volume of the metal is being given as an, that is 2 centimeter cube. That's also in the CGS system 2, and your density of the water in CGS system is 1. So from this one, 30 minus 2 is equal to VW. From this one, volume of the wood is equal to 28 centimeter cube. This will be your answer. So where it is at the option A. Now coming to your next question, that is a question number 19. A block of mass m is pulled along the horizontal frictionless surface by a rope of mass m. If the force P is applied at the free end of the rope, force exerted by the rope on the block, it's concerned to the NLM, that is Newton's laws of motion, where the connected bodies concept. So in this case, there are two masses. One is the block mass, shall we take it as some capital M, and this is your rope that is being pulled with a force of P in this direction. Mass of the rope is m. So this particular point he is asking the force applied by tension, or that thing he is asking. So what is the total acceleration of the system for the force applied? So that is F is equal to P is equal, it is pulling the total mass, that is m plus small m into A. So acceleration of the system will be the P by capital M plus small m. This should be the acceleration of the system. Now the same acceleration should also be at this particular point. Let me name it as an some O. So the tension at that particular point O is, this point has to pull how much mass? Still it has to pull a mass of capital M. So it should be the capital M into A. Substitute the acceleration, that is capital M into P by capital M plus small m. This should be your force or the tension at that particular instant. So m into capital M into P by capital M plus small m, option D. Now we can go for the next one, that is then question number 20. So what is this question number 20 is, a solid sphere of mass m and the radius is surrounded by a spherical shell of same mass m and radius 2r as shown in the figure. A small particle of mass small m is released from the rest from a height h. There is a hole in the shell. There is an hole in the shell here. In what time will it enter the hole? He is asking. It's a pure case of the gravitation where there is a variation of the G conditions. So coming to this particular thing, he is asking the time will it enter the hole, he is asking. So now what can be the acceleration due to gravity near the surface of the shell, sir? So the acceleration due to gravity generally is equal to the G into, that is m by, this should be the r square. But in this case the mass has been turned out to be the G is equal to capital G into 2m by radius also turned out to be the 2r whole square. So it will be the G into small m by 2r square. This is your acceleration due to gravity, and the height it has to fall is h is equal to half g t square, and the time he is asking, so t is equal to root over 2h by your new acceleration due to gravity, that is root over 2h by gm by 2r square. On solving this one, you can get the t is equal to 2, you can take it outside, by h into r square by g into small m. This is the time taken. 2 into root over hr square by gm. 2 into hr square. This should be your option A, should be your correct option. Now coming to your next question, question number 21, that is the EMF and internal resistance of the battery shown in the figure are 4.3 volts and 1 ohm respectively. The external resistance R is 50 ohms. The resistance of the voltmeter and the ammeter are 202 ohms respectively. Find the voltmeter reading he is asking. So now when you sort it out, this particular thing, you can say that 50 ohms, that is external resistance, and this one are in the parallel. So let's draw the diagram. So in this question, the given thing is, and that is the potential is, the battery he has given it to be the 4.3 volts here, and there is 1 ohm resistance in this case. The net resistance on solving this one, so how do you solve this net resistance is R is equal to, that is, since they are parallel, 400 into 50 by, that is 200 into 50 by 200 plus 50. So solve this one, you can get the value of the R to be the some 40 ohms. So this is the across the voltmeter and this one, and your net equivalent resistance can be written as, and this is 40 plus 2 ohms plus 1, that is 43 ohms. So that's what I am representing here. This is your 40 ohms for the voltmeter and the resistance 50 ohms. Here is an ammeter whose 2 ohms here, and all of them are in the series, so net resistance is this one. So current passing through this one can be written as an V by R equivalent. V is going to be the 4.3 and your R equivalent is 43. This comes out to be the 0.1 amp. Then your voltmeter reading is, then voltmeter reading, that is V is equal to 4.3 minus 0.1 into 3. So that should be equal to the 4 volts. Fine. So this should be your answer. Coming to the next question of us. So it's a Carnot AC air conditioner. So see how this thermodynamics Carnot is a very important chapter. This is the second question that we have got in this particular paper. It's a very important. Please go through it. A Carnot air conditioner takes energy from the thermal energy of the room at 70 degrees Fahrenheit and transfers it to the outdoors, which is at 96 Fahrenheit. He has given in terms of Fahrenheit, not in degrees Celsius. Please be careful. For each joule of electric energy required to operate the air conditioner, how many joules are removed from the room? As this is an Carnot engine condition, sir. So please be careful of this one. Important concept. So what he has asked, how much energy, how many joules has to be removed from the room? He is asking the sink sort of a temperature, that is coefficient of performance of this engine is, that is beta, can be written as an, that is an Q, that is cold reservoir temperature, Q2 by your work done, or this can be written as an Q2 by Q1 minus Q2, where Q2 is the one which is going to be the heat taken out from the room, which can be written as an coefficient of performance into, which is work done. So what is the work coefficient of performance is 19.6 and into 1, which comes out to be approximately, that is 20 joules. So this is the one given in the case. Next one, 23rd one, the voltage gain of the amplifier without feedback is 100, that is beta he has given. If a negative feedback is introduced with the feedback function beta is equal to 0.5, then the gain in the feedback amplifier, actually this is concerned to the semiconductors last topic, or this is feedback amplifier conditions, please. So the gain, how to solve this particular thing? So the gain in this case is going to be the gain of the fed amplifier or feedback amplifier. So feedback amplifier is equal to, that is AI gain is equal to A by 1 plus beta A. So this can be represented as an, this is 100. So what is this 100 is, actually this is an voltage gain. What I am talking is 1 by beta. What is the value of the beta is 0.1 into 100. So solve this one, that will be the 100 by, this is the 11th one, 11, which comes out to be the 9.09. This is the gain factor, doesn't have any units. So it's one of the important concept which might be asked. Please be careful of this one. Generally students will be neglecting on this one. Now coming to the question number 24. 2-point white dots are 1 mm apart on the black paper. They are viewed by eye of pupil of diameter 3 mm. Approximately what is the maximum distance at which these dots can be resolved by the eye. He is asking the resolving power, that means wave optics resolving power conditions he is asking. So under this resolving conditions, what is the formula for the resolving power of a telescope conditions? That is, it can be written as an, that is theta or whatever it may be. Resolving limit can be written as an theta is equal to, or this should be greater than or equal to 1.22 into lambda by, this is d, where is the diameter. So from this one he is asking, this theta can also be written as an, this is distance y by capital D, distance between the slit and the screen. From this one, capital D is equal to or less than or equal to y into small d by 1.22 into lambda. This is another very important thing. Substitute all the values, please. So d should be less than or equal to the 10 to the power of minus 3 given, 3 into 10 to the power of minus 3 given. So 1.22 into your wavelength is 5 into 10 to the power of minus 7. Solve this one, you will be getting it as an approximately 5 meters. So this should be your answer. Next, coming to the 25th question. A lens has a convex surface of radius of curvature 20 and concave surface of radius 40 centimeters and is made of the glass of a refractive index 1.54. Compute the focal length he is asking. So it is a lens, one of the surface is convex surface, another one is an concave surface he is taking. So refractive index also, let's go for the lens maker's formula. It is the ray optics conditions, please. What is the lens maker's formula here? So that means one is an concave, another one is an convex, both of them are towards the positive. So that means R1 is positive, that is R1 radius of curvature, R2 is also positive. Then your focus formula according to the lens makers will be written as an 1 by f is equal to mu minus 1 into, this is 1 by R1 minus 1 by R2. Okay, so that is equal to the, this is 1.54 minus 1 into, one of the radius of curvature is 20 and other radius of curvature is 40. So solve this particular thing, that is 0.54 by, so this will be the 40, or your focus can be written as an plus 74 centimeters, plus 74 centimeters. So this is your, it is an converging lens, obviously it's a positive lens. Fine. Coming to your next question, that is question number 26. The displacement y of the particle in a medium can be expressed by y is equal to, this is the amplitude sine of omega is, this is your omega amplitude and this is the k and the initial phase phi naught, where the t is in seconds, x is in meters. He is asking the speed. So it is another case of your particle which is oscillations, you can go. He is asking this velocity is going to be how much. So how can you find the velocity in this case is, so velocity formula is v is equal to, that is omega by k. So as I have written in the question, your omega is going to be the 100 and k is 20, which is equal to the 5 meter per second. This is your another straightforward question. So next one, that is the question number 27. The half-life of a radioactive substance is 20 minutes. The approximate time interval, that is T2 minus T1, between the T2 when 2/3 of it has decayed and in T1 when 1/3 of it has been decayed, is asking. It's a nuclei chapter under the radioactivity concept, please. So it's another very important concept you need to concentrate here. So what he has given is n1, that is the number of nuclei. First, if I take initial number n0 and decayed is how much? 1/3 in T1, that is equal to the 2 by 3 n0 Rb left. And correspondingly after T2 seconds, n0 minus 2/3 of n0, this you can write it as n 1 by 3 n0. So he is asking the ratio, that is n1 by n2 is equal to half into n, that is number of half-life. You can, that is from this one you can say that n value is equal to 1. That means T2 minus T1, the time taken can be is only the 1 T half. And what is the T half value is? That is 20 minutes. So it's another thing, very important concept. Coming to the question number 28. At a certain place on the planet, the Earth's magnetic field is 5 into 10 to the power of minus 5 Tesla, directed 40 degrees below the horizontal. If the horizontal wire carries a current of 3 amperes northward, then force per unit length he is asking. It's a chapter concerned to the moving charges in the magnetism, please. Under the condition of that is the force between the conductors or force on the current carrying conductors. So in this case, what he has given is, the question he has given is it's a little bit fun. So that's a certain place on the planet where the magnetic field is, the horizontal wire is carrying. Now let us take a horizontal wire. So this is your horizontal wire in which the current carrying is 30 amperes and it is directed towards the north. Fine. So in this case, the resultant magnetic field is making an angle in this direction with respect to the horizontal, some 40 degrees it is been taking like this. So obviously in this direction you will have the horizontal component of the Earth's magnetic field. In this direction you will have the vertical component. Here it will be the B condition. Now he is asking force per unit length. So what is the force on the acting on the conductor due to the magnetic field is F is equal to BIL sine theta. So substitute all the values here, please. B is going to be the 30 and the current traveling is going to be the 30. Magnetic field is 5 into 10 to the power of minus 5, and you need to calculate the force per unit length. So I'm taking the L to the other side, into sine 40. So sine 40 degrees, you can just need to solve them. Please go for the approximations. So you can get this one as a 9.6 into 10 to the power of minus 5. This is your force per unit length 10 to the power of minus 5. And by using the right hand rule, you can also find the direction of the force. Obviously that will be the into the page. This is the condition. Next question. So a particle is moving in a circular path with a constant speed 10 meter per second. What is the magnitude of the change in velocity of the particle when it moves through an angle of 60 degrees? He is asking. It's another case of where the motion in a plane, you can go for this and uniform circular motion under this category. So now particle is been moving in a circle like this. Okay, let us be some fine here. So particle is moving in a circle in this way. So by making an angle, how much angle it is been rotating from one point to the other point? 60 degrees with a constant velocity of 10. So let me take here, suppose initially this is the first point A, and after 60 degrees it is making to the point B. So this should be the direction of your velocity V2. This is also V, obviously. This is your V1 initial velocity. This is also V. So both of them will make an angle of here. The angle between the two vectors will also be that is 60 degrees. We can go for the parallelogram law of vectors and solve this one, please. So going to the parallelogram law of vectors, that is the change in the velocity delta V can be written as an root over, that will be the V square plus 2V square cos 60, which is going to be the 1 by 2. So now you can go for this one, find out the change in the velocity condition, sir, please. Change means this value has to be the negative. So that should be the V square plus V square minus 2V square cos 60 1 by 2. Remove this one, V square cancels. Change in velocity is V, which is equal to the 10 meter per second. Okay, now coming to the next question of this one, and the last question is, a transformer consisting of the number of turns 300 turns in the primary and 150 turns in the secondary gives output power of 2.2 kilowatts. The current in the secondary coil is 10 amperes, then the current in the primary he is asking. So it's another simple one, or you need to be more concentrated, because simple questions may lead you to the wrong place. So number of turns in the primary is 300 and the number of turns in the secondary will be equal to the 150. So the power, output power, that is P2, I will be writing here, which is 22 kilowatts, and the current also in the secondary coil is 10 amperes. From the power and the current we can find out the voltage in the secondary, that is P2 is equal to I2V2, which is 22 kilowatts. 22 into 10 power 3 is equal to 10 into V2. So remove here, your potential that is across the secondary will be equal to the, which is 20. This is the finally calculate this particular thing, sir. So that is 22 into 10 power 3. 10 will goes off, which will be the 2, 2, 0 and another 0 here. This is your potential in the secondary case. So as we have got the potential in the secondary conditions, so we need to find the current in the primary. So now we can solve in this case, that is the potential in the primary is equal to N1 by N2 into potential in the secondary. So this ratio will be obviously 300 by 150 into 2200. So remove this particular thing, please. Remove this particular thing. So here actually this is where I have committed this one. This is actually 2.2. So this should be the 220 volts. It has to be the, so here also it should be the 220 volts. Fine. So on solving this one, this can be written as an, so how much value you will be getting it as an V1, sir? So V1 will be, you will be getting it as an, this goes for 0 and this goes for obviously 20 times. On this one you can go for it as an 440 volts in the output. So current in the primary can be written as an I is equal to V1 by V2, V1 by V2 into I2. So on solving you will be getting it as an 5 amps, or else directly here also you can get it by taking it as an N1 by N2 is inversely related to the same question. N1 by N2 is equal to I2 by I1. N1 is 300 and this is 150 is equal to I2, that is the current in the secondary is 10 and current in the primary you can get it. So this is an actually what initially I have done is an lengthy process. This can be done directly like this by the 2 steps here. So why I have gone for all these lengthy process means to identify you all the values whatever we can use in this particular transformers. Thank you. So this is our conditions, this is our all the best for you.